Hello everybody, this is lecture 15. In this, we will discuss about irradiation of fruits, vegetables and spices. We will study radiations and ionizing radiations, then food irradiation technology, different irradiation sources and its characteristics. Then finally, we will see the effects of irradiation on microbes, changes in foods, particularly in fruits, vegetables and spices during the irradiation process. There are several radiations type that have the characteristic ability to ionize individual atoms or molecules. You can see here like that high energy photons, when it bombards an atom, then it transfers its energy on the electron. The photon with reduced energy goes out, and when energy in the outer orbital electron it is increased above a certain level, it comes in the excited state and finally it ejects the orbital electron. So, a positively charged atom and negatively charged electron is formed. So, M is M plus E minus. In this we have shown the radiation spectrum, non-ionizing and ionizing radiation, but this is the radiation which has the ability to ionize atoms or molecule are known as ionizing radiations, and they are used basically in the food processing. Ionizing radiations, as I told you, they interact with the irradiated material by transferring energy to electron, which are thus raised to high energy or excited state, and then this finally leaves that if the transferred energy is large enough, the negatively charged electron can leave a molecule, with the result that a positive ion is formed. And the ejected electron which comes, it will not sit idle, it will move through the surrounding material and will lose its energy by creating further excited molecules and positive ions. Alright, and therefore, for every primary ionization there are secondary tertiary ionization reactions takes place and a series continues, and the chemical effects normally which is seen in the food material is more because of the secondary ionization reactions. So, you can say eventually the electron is captured by a positive ion or is captured by a structure to form a negative ion, which in turn combine with the positive ion. So, it is this ability to create positive and negative ions that characterizes the ionizing radiations and which is used to advantage in the food processing operations. The ionizing radiations may be electromagnetic radiations or particular radiations. There is mostly gamma rays, X rays and beta rays. These are the one that is which can be generally which are used. So, the gamma rays, X rays and beta rays, they have low LET value. LET is the linear energy transfer, that is measure of the energy dissipated per distance travel in the biological material. So, these because of their high penetration power, they can travel deep, penetrate deep into the material, so that the energy is dissipated over a long path. So, accordingly the per distance travel energy is dissipated is less, and therefore, they are less ionizing, whereas the alpha particle and protons, they have high LET value and therefore, they are densely ionizing. The dose unit of measurement, that is the dose of radiation, the quantity of radiation absorbed dose by the food. It is normally rad is used for this purpose. So, rad RAD is the deposition of 100 ergs per gram of the in the irradiated sample. The radiation which can deposit 100 ergs equivalent energy in per gram of the irradiated sample, which is known as 1 rad. So, 1000 rad is equal to 1 kilo rad, but recently another unit gray has been used in the food irradiation technology. So, 100 rad is equal to 1 gray, accordingly 100 kilo rad will become 1 kilo gray. Then these ionizing radiations, they have the various effect on the living organism, and particularly the dose of the radiation required to produce a lethal effect varies with the complexity of the organism. You can see here in the figure I have shown that the most complex organism tend to be the most sensitive to radiation. For example, a few hundred rad is lethal to human, but the destruction of some microorganism requires million of rad. Okay. Then let us see how these ionizing radiations work. What is the mechanism of their action against microorganisms, how they kill. So, there are two theories has been put forward. One is the direct action mechanism, other is the indirect action mechanism. In the direct action mechanism, this is a chemical event as a result of the energy deposition on the target molecule. In this, it is considered that the ionizing radiation directly hits the genetic material of the organism in the genetic component like DNA, RNA, etc., and it produces the change. Okay. That whereas in the indirect reaction, it is the radicals formed from the radiolysis of water or other reactions originating outside the cell. So, it is and which that is mutational changes and other changes may be there in that, and which finally results into the killing or inactivation. Okay. Living cells cause sprouting and spoilage. So, DNA damage delays the spoilage and prevents sprouting, it promotes longer shelf life, etc. Okay. The food irradiation, in the technology of the food irradiation, here basically the food is exposed to control energy, that is calculated amount of ionizing radiations. Normally in the food processing, gamma rays which is produced from cobalt 60 source, IX rays with energy up to 5 MeV or electrons up to 10 MeV, they are used for in the food processing operations various purposes. Radiation kills the microorganism without raising the temperature of the food. However, the contamination can occur post treatment. So, one has to take care of that this food, irradiated food should be properly packaged and handled carefully post treatment. Technology of the food irradiation that is rad appertization, where generally high dose more than 4.5 m rad or even more, and it is almost, you can say it is the radiation sterilization, equivalent to the sterilization in the heat processing. So, when instead of heat, when we are using radiation, then it is the rad appertization. Then radiorization, it radiation pasteurization, it is the medium dose, maybe 100 to 1000 kilorad, where vegetable is sprouting, fruit ripening, insect sterilization, etc. is taken care of by radiorization. It kills 90% of the microorganism. Radiocidation is a further low dose, maybe 400 to 600 kilorad, which kills most of the pathogens and many food spoilage microorganisms, insects and parasites, etc. Okay. Food irradiation sources, as I told you, that is the cobalt 60, that is a radioisotope which is used. It has cobalt 60 emits 2 gamma rays per disintegration, and these rays have energy value of 1.33 and 1.17 MeV. However, the cesium 137 which emits 662 keV that energy radiation, this is also has a potential to be used. So, the gamma rays, that is radioisotope cobalt 60, has half life of 5.27 years. It is produced in plaque sources consisting of flat strips which may contain, that is even each strip can contain more than 10,000 curie or so more. Okay, so, the number of such maybe 10 such strip, 20 such strip, 30 such strip, depending upon the capacity of the plant. They are produced, assembled in the remote controlled operations, and the source is immersed in 25 feet or 30 feet deep storage pool of water when not in use, to just to take care that there is no leakage of radiation in the environment. The machine sources include, that is the which generate beta rays and X rays. It produces no waste outside the machine used to produce the radiation. A beam of electron is accelerated by an electron gun similar to a TV tube accelerating electrons toward the screen. It can be turned off and on since it is no radioactive material. So, electron beam can only penetrate about 1 inch deep into the material. Here in this table I have given, that is what food can be irradiated, normally fruits, vegetables, spices, etc., and what are the dosages, etc., like low dose less than 1 kilogram sprouting inhibition, maybe 0.05 to 0.15 kilo gray is used for sprouting inhibition of potato, onions, garlics, okay, to delay in the ripening of the fresh fruits and vegetables. 0.50 to 1 kilo gray is used. Then medium dose, which is considered 1 to 10 kilo gray, that is reduction of non-spore pathogens, or even microbial reduction in dry product like herbs and spices, etc., in the range of 7 to 10 kilo gray. And high dose, about 10 to 50 kilo gray, is used for sterilization of the army diet rations, etc., or which has one wants the longer shelf life. Okay. Then let us see effect of irradiation or radiation on food, that is, it prevents the food poisoning as well as food spoilage microorganisms, food poisoning microorganisms like E. coli, Salmonella, Campylobacter and other parasites. It prevents spoilage by destroying molds, bacteria and yeast. It controls insects and parasites infestation. It increases the shelf life by slowing ripening of fresh fruits and vegetables. And as far as the stabilization of the food by irradiation is concerned, that is obviously when by using the irradiation we are inactivating the microorganisms and enzymes present, etc., the food gets stabilized. However, by protecting the stabilized food from recontamination and access to oxygen is important. Okay? Otherwise, that is, it should be properly packaged. The stabilization of food with ionizing radiations involves two major considerations. That is, one, the food characteristics. Depending upon the known characteristics of the food, one can calculate. We calculate normally how much, that is, in the food, the pH classification, other classification, what are the various components, that is, which will favor, that is, on the basis of this, you know that what type of microorganism may be present in the food, because the pH classification, other characteristics, it is almost which we use in the thermal processing, the same thing hold good here also. But so food characteristics, its components, pH, etc., will let you know, that will decide how much ionizing radiation, how much energy is required to be given. And then secondly, you should have a suitable source to produce that radiation. Okay. So, depending upon the food characteristics, obviously the microbial death kinetics becomes here also an important factor. That is, when food is exposed to radiation, then death of microorganism may take place, and it can be obtained by evaluating by plotting logarithm of the fraction surviving organisms against the dose. And you see here in the plot a plot of ln n0 by ln n by n0 is a linear with dose of radiation, and it is obvious that equal dosage of the microbial population decrease by given factor, and relationship between this, that is a kinetic model for this radiation inactivation of the microorganism, is n is equal to n0 e to the power minus d by d0. Okay. N is the number of organism after irradiation, n0 is the initial number of organism, d is the dose of radiation received, and d0 is a constant depending upon the type of the organism and the environment factors, and it causes generally death of 63% organism. Sometimes even d10 is used, which is a value causing a reduction in number by a factor of 10. Okay. So, that is the, in this let us see that factors which affect the radiation sensitivity of microorganism, both the environmental factors during irradiation as well as physiological and genetic differences between the strains and cultures of microorganism can affect the radiation sensitivity. Like type of irradiation, type of radiation will not affect the radio sensitivity of microorganism. Whether you are using X-ray or gamma rays, etc., required dose of radiation has to be given. Similarly, dose rate, intensity of the radiation, it also generally does not influence, it does not affect the radio sensitivity. Okay. Whether you are giving at a fast rate or you are giving the radiation at a slow rate. However, it may affect the environmental temperatures, etc., environmental factor. Presence of oxygen also does not have a significant effect, as do the pH and type of the medium in which the food is being irradiated. Then state, irradiation in the frozen state reduces radio sensitivity of some microorganisms. Sterilization through radiation of food in frozen state minimizes chemical and flavor changes in food. However, greater dose is required in the sterilization, for the sterilization in frozen state. temperature has the effect on sterilization requirement. This effect forms the basis of the potential combination process utilizing both heat and irradiation, because it has been seen that there are some heat sensitive bacteria or microorganisms, they are resistant to radiation and vice versa. So, this is taken as a beneficial, and a combined thermoradiation process is used. Very high temperature, if it is used, it may add to its own lethal effects. Okay. So, now let us see that what are the various changes in the food constituent during the irradiation, because irradiation is considered as a cold process. It is referred to as cold pasteurization or cold sterilization process. There is no involvement of heat. It can accomplish the same objective as is done by the thermal pasteurization and thermal sterilization process of the food, but without involvement of any heat. So, there are very little or no change in the physical appearance, no textural or color change, even some chemical changes which may affect some flavor or tissue softening, etc. maybe they are depending upon the dose and type of the food, etc. There are chemical changes which are brought into the food, that is the chemical effects of ionizing radiation, like and let me tell you that ionizing radiations are capable of initiating a vast array of chemical changes in gaseous, liquid and solid system. It may include radiolysis of water, or it may include the effect on macromolecules and other components like protein, carbohydrate, lipids, vitamins, enzymes, etc. So, radiolysis of water, effect of ionizing radiation on water, that is radiolysis, that is or ionizing radiation, they split, or more technically as we call radiolyzed water. Okay. And since most of the foods are aqueous system, this effect of ionizing radiation on water is of key importance. Particularly important it is in fruits, vegetables, etc. They contain high moisture. Okay. So, the passage of ionizing radiation through water results in the formation of the various intermediate like excited water, free radicals, ionized water molecule or hydrated water molecules. So, these free radical intermediates, they then react among themselves or they react with other component of the food system. And if there is any pure water only, when there are only these intermediate, then hydrogen gas, hydrogen peroxide, a fresh water molecule, hydronium ion or hydroxide ion, etc. are produced as a result of interaction of these intermediates. And the reactions these intermediates can undergo with the food components are huge. There are numerous, there are various reactions that is which takes place, and depending upon the type of the other commodity, like they may interact with protein, fat, carbohydrate, etc., etc. Then one was the radiolysis of the water. Ionizing radiation has also direct effect on the hydrocarbon chain, that is hydrocarbon chain are present in the lipid as well as in many polymers in food packaging material, etc. So, direct action of ionizing radiations on hydrocarbon chain, a number of primary events can occur. That is most important event is abstraction of hydrogen from the hydrocarbon chain, and there is a concurrent formation of the free radical like carbohydrate polymer chain, hydrocarbon free radical and hydrogen free radical is formed. And these hydrocarbon radical then can again undergo a large number of reactions, among those involving the reactions with atmospheric or dissolved oxygen, cross-linking, condensation, polymerization, so many reactions can take place. The effect of vitamin, if you want to see that vitamin C, E and K destruction depends on the dosage used. Thiamine is very liable to irradiation. The doses are also low with low dose. The ascorbic acid in the solution is quite liable to irradiation, but in fruits and vegetables seems quite stable at low dosage of treatment. Vitamin which has antioxidant activity such as A, B12, C, E and K, and thiamine are degraded with irradiation when it is carried out in the presence of oxygen. Effect of ionizing radiation on enzyme. Okay. It is known that the enzymes are generally resistant to ionizing radiations. Complete inhibition of enzyme require about 5 to 10 times the dose required for the destruction of microorganism. The D value of enzyme can be 50 kilogray and almost 4 D value would be required to complete destruction. So, irradiated food will be unstable during the storage. Enzymes in food must be inactivated prior to their irradiation. Okay. So, these effects however can be minimized, that is in the effect of ionizing radiation on food constituent, by lowering the water activity. Less free radical will be formed because of the residuolysis of the water. So, irradiation in the dehydrated state has been beneficial. If there can be less aerobic conditions maintained in the irradiation facility, so that even oxidation related changes will be minimized. Reducing temperature, that is the sub-freezing radicals, that is immobilized free radicals, like freezing in the irradiating in the frozen state, or even addition of free radical scavengers, or simultaneous distillation during irradiation. It helps to remove volatile or flavors, etc., or flavor precursors, and these effects can be minimized. And one very important thing, that is the wholesomeness of the irradiated food, whether it is wholesome for consumption or not. And in this, one is that it is taken as the induction of any radioactivity, whether after irradiation food has induced any radioactivity or not. So, the induction of radioactivity in food depends upon the type of radiation and its energy, the dosage applied to the food, and the abundance of specific elements in the food. In addition, half-life of the induced isotope, since it is very short, if it is very short, then isotopes disappear before the commodity irradiated food reaches the consumer. So, these are some of the factors. However, it has been seen, this aspect has been thoroughly debated, and it has been seen that irradiation kept under the recommended level control condition does not produce any harm. So, induced radioactivity can be calculated by this Harassman equation, where Q is equal to 30 dEn by T. D is the total dose in mrad, E is the energy of radiation, N is the decay constant, and T is the half-life of the isotope formed. Okay. This is the gamma irradiation facility in India also. There is a, in the Lasalgaon there is a facility, in the Bark there is facility. In fact, that so in this facility you can say it is gamma irradiation. So, it is the storage area in the pool, the radioactive material in the pool of water it is used. Then it is loading area, the food in packaged or unpackaged form is loaded here. It goes follows a zigzag path, and it is the radiation room. Means when the material comes here, then the source through the remote control operation is taken up and it emits the radiation. So, in the required area, it is gives the desired dose of the radiation, and then it goes again, take a tortuous path, comes to the unloading area. And this, there is a concrete shield, radiation shield, that heavy walls are given just to take care that radiation does not come out of the room to the environment. So, obviously, that is the scope of irradiation, food processing, disinfestation, shelf life extension, decontamination, product quality improvement, etc. are there. That is, it can be used as an alternative to chemical fumigation in the spices and in the fruits, etc. Okay, it can increase in the international trade. In fact, India has already signed that an MOU with the US, that is Singh-Obama agreement. Under this, the Alfonso mango is irradiated in bark, and then it is shipped to US. So, irradiated mango is available to improve public health, minimize food losses, etc. So, now let us see effect of irradiation on fresh fruits and vegetables, like retardation. It results in the retardation of the ripening. Irradiation is able to alter the production of substrate and enzyme involved in the ethylene biosynthesis, and therefore, ethylene production rate is minimized and the respiration ripening is retarded. So, low irradiation dose delay the post harvest ripening of many fruits, and it is so that the banana 0.2 to 0.4 kilogray is sufficient. In the apple, pear less than 0.9 kilogray, mango less than 0.2 kilogray. So, these are the doses given which will delay the reduce the ripening rate. Post harvest weight loss in the fruits and vegetables, that is a higher dosage, maybe more than 1 kilogray irradiation can significantly modify the microstructure of vegetable tissue and consequently their barrier properties and susceptibility to post-harvest dehydration. The changes in these properties can flavor or reduce the post-harvest weight loss. That is, weight loss in grapefruit, navel oranges and other fruits with cracked peels increases with the irradiation dose. Fruits having thick peels showed decrease in the weight loss. Okay. Firmness, effect on the firmness, that is a decrease in the firmness is manifested immediately after an irradiation and can be observed at low irradiation doses less than 1 kg in raspberries, kiwis, blueberries or some apple varieties, okay, some pear varieties, papaya, oranges, etc. At low irradiation doses, the firmness loss does not exceed 10% of the initial firmness. The direct alteration of the structure of the cell wall polysaccharides like peptic substances is likely the major cause of softening immediately following irradiation. That is effect of these irradiation on the peptic substances, etc. Then the color of the fruits and vegetables as visually evaluated is generally not altered significantly by the irradiation. That is, instrumental evaluation showed little changes in the stimulus color, that is there is decrease in L star value or lightness value due to darker external surface. The change in the is consequence of direct alteration of pigment. There may be modulation of enzyme activity, biosynthesis and ethylene production. However, in most cases the irradiation mediated changes in the pigment is not manifested in the tri-stimulus color values. Effect on sugar, that is irradiation can increase or reduce the content of the sugar in fruits depending upon the type of the fruit. That is, for example, low doses less than 1 kg gray, only small increase or decrease in the TSS is seen. Higher doses more than 1 kg gray is do not alter the content of individual sugars in plumoles, or very low doses in between 0.075 and 0.3 kg gray. Also they do not alter the content of glucose, fructose, etc. They cause slight but significant increases in the glucose content in custard apple. There are reported decreases in glucose and sucrose in mangoes and imperial mandarins under these very low doses. As far as the effect on vitamin is concerned, we have seen already irradiation alters contents of some vitamins like A, B1, C, E, which is mostly as a consequence of the free radical generated by radiations. So, vitamin C is less than 1 kg gray, there is a 10% less than 10% decrease at 1 to 6 kg gray, 18 to 47% vitamin C losses are reported. Alright, in the vitamin E less than 1 kg gray do not affect, 1 kg gray 40% loss of vitamin E in tomato, 2 kg gray for 10% loss of vitamin E in spinach is reported. As far as B, similarly 0.2 to 1 kg gray increases thiamine and riboflavin in peas, 0.75 kg gray level increases riboflavin in papaya, and 0.5 to 5 kg gray decrease in vitamin B in jujube food. Inhibition of ripening, you can see low dosage of gamma radiation 0.06 to 0.15 kg gray inhibit sprouting in potato, and these are the pictures shown here. In this, that is the various doses unirradiated and then irradiated with different dosage, and you can see, and they are stored for 120 days at 22 degrees Celsius. In the second picture here, it is unirradiated sample 0 kg gray and irradiated, and this is the Kufri Sindhuri variety, and these were the Kufri Sindhuri tubers, both are the Kufri Sindhuri, but they are the dosage varying, that is 120 degrees Celsius. How these are varying, okay, unirradiated and irradiated sample. So, this is stored for after 30 days, after, that is, this one was, it is irradiated just after 5 days of the harvest, and then you see the change, and this is irradiated after 30 days of the harvest, and then you see the change. And in both the cases, that is, even when you are irradiating after some longer period, it requires higher dose to produce the similar effect. Then effect of irradiation on spices. It is irradiation of spices is done particularly for microbial and insect decontamination, insect disinfestation. Gamma irradiation at the rate of 10 kg can eliminate microbial load without any significant organoleptic or chemical alteration. A dose of 2.5 kg reduced the fungal and bacterial load by 2 lakh cycles, and 7.5 kg eliminated the fungal population of ground or whole pepper. A dose of 0.15 kg in garlic can inhibit sprouting and reduce weight loss. However, the flavor compound diallyl disulfide decreases. Low moisture 10% product are prone to the formation of free radicals, which lead to the increased production of oxides and sometimes even alcohols. So, this effect of the sensory attributes of the spices like low moisture foods such as dried herbs, spices, seasonings, seeds are generally not affected in their sensory qualities even at a relatively higher dose levels. The free radicals generated by irradiation can influence the components that are responsible for texture, taste and appearance. It seems that small differences caused by low dosage on sweetness, color, flavor and aroma are often not perceived by the consumers. More obvious changes in the appearance such as browning, pitting, softening are more perceptible and may cause negative impact on the sensory quality. Consumer acceptance, it is the measure, that is the consumer acceptance of irradiated food has always been a challenge, okay, and it immediately goes in the mind of the people whether it is safe to consume or not. But let me tell you, this is a purely safe provided if irradiation is done under controlled environment and recommended level of dosage are provided, given. Okay. The acceptance of the consumer is further hindered due to the lack of understanding how the irradiation work has been done. So, at least for this reason, now many countries they have recommended it is being processed, including in India. In our country, irradiation is officially permitted and it is being used for the irradiation of spices, fruits, vegetables, etc. Okay. Then labeling of the irradiated food as per the FDA, this Redura label, it is a must, that is all irradiated foods must bear the Redura label and state on the label that treated with radiation or treated by irradiation. Many countries have their own regulatory requirement for food irradiation, and also there are many countries which do not have any regulatory requirement, any specific to irradiation, and even many countries in the world, a few European countries, they have yet not permitted irradiation in there. These are some of the picture of the irradiated strawberries. You can see after harvesting, 5 days after harvesting and 3 weeks after it is irradiated, that is untreated and irradiated. Strawberries 25 days after treatment and storage at 3 degree, where is the control, no irradiation, irradiated 1 kg and irradiated 1.5 kg. Okay. So, these are the even sugarcane sticks, the control 36 days at 34 degree Fahrenheit and irradiated with 400 gray and 36 days at 34 degree Fahrenheit. You can see the difference. So, irradiation has been proved to be a successful technology provided it is conducted properly. And one thing is important, that since it is the involvement, you are the gamma rays and all those radioactivity etc. is involved. So, it is regulated, at least in our country there is AERC, Atomic Energy Regulatory Commission. So, anybody if you wants to establish a irradiation facility, so one has to take permission from the AERC and FSSAI approval etc. is required for things. So, these are the, now finally I will summarize the lecture by saying the food irradiation has versatile application, but has not been utilized to its full potential in several countries. Ionizing radiations are high energy radiations, hence along with the desirable effects, they are also expected to produce certain undesirable changes. by their interaction with different structural and chemical components of the food, and that should be properly taken care of. At higher dosage, irradiation is used to prolong the shelf life of foods by destroying vegetative cells of yeast, fungi and spore forming bacteria. Irradiation in low dosage below 1 kg is effective in inhibiting sprouting of potatoes, onion, garlic and delaying the ripening in fruits, both to extend the shelf life. These are the references used in this lecture. Thank you very much for your patience hearing.